Hello, my friends, and welcome to exercise 7. Hopefully your memorization is going well. Again, just stick with it. Trust me, the memorization is going to be so good for you. It's going to make things so much easier. Now, in this one, you can start going through this. You should be up to where you've memorized the keywords that are necessary for types. So this code should go a lot simpler and a lot easier for you. So our plan for this lecture, and I'm going to repeat something, you should also be going through the book. You shouldn't be just using the videos. The book has even more explanations of things. So make sure you go through the book too. So we're going to look at the code real quick. I have a full breakdown of the code in the book, line by line. It would be good for you to read this, okay? But I'm going to go through the code right now, and we're going to cover ints, floats, doubles, characters, and then strings. Strings are a little odd in C, so we're going to have some fun with that. And then after that, we're going to break it. So let me just go through the code. Remember, I'm not going to type this code in. You're on your second programming language. You don't need to see me type code in. Watching me type code in a video is just not optimal. It's not very fun. Just read the book. The book has the code. You should get used to copying the code out of the book, but also being able to learn from books. Now, we're doing our usual beginning of the C program. And what you can see is, just really quickly, we're doing a bunch of different variables. I'll get in the analysis part of this lecture, I'll go more into this. We're printing those variables out. And then we're just sort of going through all the different types and things you can do with them. All right, that's the code. Read it from the book, type it in from the book. And also remember, if you grab the lectures GitHub repository, the code is right here, so you can compare my code to yours. Let's take a look at the analysis of this. What we're doing in this exercise is it's basically a bunch of gibberish. This exercise doesn't do anything useful because you shouldn't focus on what it does. It shouldn't be that this does anything that needs to be correct. What you should focus on instead is not the content, but the actual types and the data that's being used. And what I do is I go first with integers, floats, and doubles to show you how those work. Make sure you know that that's your F there says that it's a float. And the difference between float and double is float is smaller than a double. That's the easiest way to remember that. Then I create a single character, and also notice, unlike in Python, Ruby, other languages like that, the single quote is only for one character. You can't do this. That makes no sense. If you want to do more than one character, that's a string. We will get into strings, pointers, arrays, all of that later. But for now, one way to define a string is to do this. Remember, what are these two? These are the array subscript. And then type your string like that. Everything when you do data in C ends in a semicolon, except for, like at the end of structures like that. Doesn't need a semicolon. Great, we have some data. Now we can use all the different formatting from printf. So I just literally go through and I just print out each one. You should make sure that you notice the difference. See how I have %C here, %S? That's the difference between printing just a character or printing a full string. Next, some gibberish with bugs. Not a big deal, just showing you that I can put more than one thing in there. Then I do some math. You should see I'm doing a long. So this is going to sort of be shorthand for a long signed integer. And with that, I can put L, and C will know that these numbers should be considered long numbers. And then I print that out with LD to make sure that I have a long decimal printout. The D is just, for decimal. It's mostly historical. It's the same in a lot of languages. I then next have a demonstration of, multiplying a double by an int to kind of show you how that gets translated into a double. So C has a type promotion system that will convert things to different types, and we'll get into a lot of that later. So if you go into the book, exercise 8 is on if-else, and then exercise 7 is just types, and then later we get into more complex types later on. And then I do some division. And then the last thing is I do something sort of strange. This shouldn't make any sense. It's just a demo that you can use. But I create a character and I set it to the null byte, which usually is a 0. So it depends. We're using the ASCII character set, and yeah, it'll just be 0. And then I'm multiplying that times bugs, so we can see what that has when we're done. Another key thing to remember is if I want to print out percentage, it's %%. So let's make this and see what this does. Make ex7 and run it. And there you go. And again, this last part, it converted this null byte into a 0 and multiplied it times bugs, which gave us our 0. You can also see I've printed out exponential notation. That's what the %e does. And it would be good for you to go through each line of the printout and match it with the printf. And also, as you go through this, integer variable assign 100. You can do that. You can go through and translate. You know what this is. It's an integer. You know what that is. That's going to be a variable. You know that's the assign, or you could even say equal. But take your knowledge that you have now of C keywords and do your comments above each keyword as the name of the keyword for practice. Okay, so breaking it. We can do a lot of really fun things with breaking this. So let's see. See how we have this? We can do, here, let's do the first one. First name, and let's see, I think I can do that. And what did it print? I have a first name. Yeah, it printed nothing. See how that happened? Okay, so what this does is first name, and we'll get into this later, is pointing at the beginning of this, okay? And then I can sort of make a mistake. Maybe I just did the variable name wrong, or maybe I did it wrong, and I move the first name to, if you were thinking of this as the RAM of only 3, it's stored in memory for 3, I pointed it like at way over here, off to the side. So because I did that, it printed out whatever was in memory there. So let's see if I can make it crash at some point. Let's try the next one. Now, just printing names. So we just have a bunch of zeros in the RAM right now. Let's see, what else can we do? I could come up here and I could modify. Let's do first name should be 4 equals 1. That's going to do some funky stuff. Yeah. So see, I have an error. It's telling me 4 is past the end of the array because I've said that this is the fixed size. Oh, let's do 3. Let's do 3. Yeah, because 4, I'm off by 1. So 4 is actually past the end. Okay, so this is valid. Actually, let's do that original one. So an off by 1 error is really common. So make, and it still ran, for the most part, but it just sort of did some weird stuff. All right, let's try another one. Let's do... Oh, interesting. See how it did? It wiped out the A. Very funny. So yeah, let me show you this really quick. So first, let me undo that, and we'll make, and then we'll go like that. Okay, so see how the Z-A Shaw shows up? The A shows up there. Now when I put this back, I went past the end of the array. C lets you just trample all over memory, and I put a 1 there. So now when I do this, I make it, and now see the A goes away? See how the A disappears? So now check this out. I could probably do this. I could probably go like, I'm going to change it to Z, and then my middle name, my middle initial will be Z. So let's try it out. Yeah, see? Weird, right? So I basically, using the pointer for this first name, went right past the end of it at index 4 instead of 3, and that ended up being this piece of RAM there, and reset it to something else. Let me do one more. Let's change it to the @ symbol. Yep, see? C is weird. C is very weird. So let's do this. We're going to break the string. So this is totally valid. Remember, indexing into arrays starts at 0. C is a 0 base one. So this is 0 for the Z, E is a 1, D is a 2, and then C terminates its strings with a null byte, with this character. So we'll get in a lot of that later on. But if I set this null, if I set index 3 to a Z, then that will remove the null byte, and then the printf functions will trample right over RAM and just print whatever happens to be there. So let's see what that does. And notice, I got no errors. There's no compiler error. Yep, so see how this looks? Bam. So basically, the printf function just went and printed all the characters. It got to that Z we tacked on. This is the A that we changed when we changed our variable name to A, or middle initial to A, and then just trample. This is all just basically probably garbage bytecodes and things. And then it finally hit a 0. Now, when you do this, your memory in your computer might be organized differently. So you might run into, you might not have anything happen. You might do different stuff. But experiment with this. How can you bust these things? This is a key thing of these videos, is getting you to assume that the computer is basically working against you, or C is not helping you out. And so you have to assume that bad things happen, and how can you cause them to happen? All sorts of things can be done with these strings, which is why I wrote them this way. Find out what you can do with changing indexes and things like that. So we craft bad strings, we mess with the pointers, that's what happens. We'll get into what pointers are, but if you just add, like how I added 100 here, that's how you do that. That's how you mess with pointers in a lot of ways. And let's see, and we abused printf. We didn't really do too much abusing printf, but when we just basically printed all that stuff out. All right, the extra credit, this is also in the book. Make sure you read the book. Make the number you assign to universe of defects various sizes. Try to do really huge numbers. So how large can you make these numbers? Go find out what the size on your computer is. Like, how big is your long? How big is your unsigned long? What happens when you make an unsigned long too big? That's something that you should do. And then, what does unsigned do? In case you can't find anything online on what unsigned does, what it does is basically, signed lets you have negative numbers and positive numbers. So it will go to a certain amount of negative and positive. Unsigned basically doubles the amount you can have, the size of the number, but only because it starts at 0 and goes all the way to double the max of an integer. It basically takes 0 and moves it down, or basically takes all the negative number space that you have in a signed integer, and it gives it to you as one extra bit within, or extra bit within the thing, so that way you, within the number, so that way you have unsigned amounts. And then explain to you try to explain to yourself what happened when I multiplied char and an int together. That's going to be really important. It's a weird thing of C. C sort of doesn't care what's in RAM. You're telling it this is a character or that's a character, but it really doesn't care. It lets you kind of get away with a lot of stuff it shouldn't let you get away with. So, what happened? That's the end of Lecture 7. I'll see you later.